So in chapter 8, question 16 says a 68.5 kilogram astronaut. So we'll have the mass of an astronaut is equal to 68.5 kilograms. A 68.5 kilogram astronaut is doing a repair in space on an orbiting space station. She throws a 2.25 kilogram tool. So the mass of the tool is equal to 2.25 kilograms. She throws the tool away from her at 3.2 meters per second. So the velocity of the tool in the x direction, is 3.20 meters per second. Okay, and it wants to know with what speed and in what direction will she begin to move. So basically what it wants to know is the velocity of the astronaut in the x direction. So we want to find velocity of the astronaut in the x direction. So basically what it's saying is if she's right here and she throws the tool this direction in the positive x direction at a velocity of 3.2 meters per second, based off her mass and the tool's mass, she will move back in the other direction, in the negative x direction, a certain amount. So what we're going to do is we're just going to take these values and plug them into this, the formula for the conservation of momentum. So I'll erase all this. So the mass of the astronaut is 68.5 times the velocity of the astronaut, which is what we're trying to find, plus the mass of the tool, which is 2.25, times the velocity of the tool, which is 3.2. And since they're going to be offsetting, in opposite directions, they're going to be equal to 0. So now we just want to solve for the velocity of the astronaut. So what we'll do is we'll just subtract that across. So now we have 68.5 VAX is equal to negative 2.25 times 3.20. Now we'll just divide both sides by this, and we have the velocity of the astronaut is equal to negative 2.25 times 3.2 over 68.5. And we know that it's going to be in the negative x direction because of this negative right here. And so I punched that into the calculator, and I got negative 0.105 meters per second. And that's in the negative x direction, so she'll be moving backwards at 0.105 meters per second. And that's your answer.